Hey everyone, welcome back to my channel. That is me, Kushi, and today we're going to do the next module of Python. So this is actually the sixth module. So let's get into it. But before that, make sure that you have watched all my previous videos, because to understand this video, it is necessary that you have understood all the previous concepts. So let's just get into it. So the first topic is none. So none actually represents absence of a value. Now, for example, I have a variable, let's say x, and as of now I don't know what is the value for x. So for now I can let it be, either I can write a 0 here, either I can write these empty square brackets. No, we can't do this for a variable, or either I can directly write null or none, whatever we are supposed to write. And later on in my program, if I got to know the value of x, now let's say the value of x is the, and then I can just print it out and the value of x will be printed as the. So this is used in cases where you at the initial stage do not know the value of something, but later on you come to know what the value of that particular thing is. None often represents the absence of a value. The none object is returned by any function that doesn't explicitly return anything else. Now, let's just take two different examples here. So the first one, we have two variables, let's say x and y. X is having a value, let's say 1, and y is equal to none. Now here, if I ask the computer to print both x and y, only the output of x will be given, not of y. And in the second case, let's just take an example that we have only x whose value is none. And if I ask the computer to print x, there will be no value, which means that in the second case, x, which is none, is being printed out. But in the first one, it is not being printed. So that is what the sentence tries to explain. So the next concept is dictionaries. So dictionaries are actually very much like lists. So let's just see what exactly they are. So dictionaries are data structures which are used to map arbitrary values. Lists can be thought of as dictionaries with integer keys with a certain range. So here we have Dave is 24, here name Dave and the age. So here actually we specify things for each person. So now for example, I have Dave, which is a name, and we have 24, which is his age. Now in the same way we have Mary, we have John, and this can go on to many numbers. Now when I ask the computer to print Mary, it will print out the age of Mary, which is 42. And if I ask the computer to print out John, it will print the age of John, that is 58. So this actually works in a key and value pair. So the value represents the key and the key represents the value. Now trying to index a key that isn't part of the dictionary returns a key error. Now this is as the same thing of lists. You can also make empty dictionaries by just keeping those curly braces empty. Only immutable objects can be used as two dictionaries. Immutable objects are those that cannot be changed. Now, for example, in my program, let's say I've given the value of k equal to 2, which means that later on I cannot make its value to something else. These values are not supposed to be changed. Somewhere else in my program, if I decide to change the value of k, this is not actually possible. Now let us look at the next one. So now we have dictionary functions. Now how a dictionary used in functions and what are some of its profits in the ways it makes our program simpler. So for dictionary functions, just like lists, dictionary keys can be assigned to different values as we know. However, unlike lists, a dictionary key can also be assigned a value, not just the ones which already exist. So I can just actually change their values. Like since now here we have 1:1. These are actually the squares. 2 is 4. The square of 3 here I've given error. And 4 is 6. So this is the way, sorry, this is the way it is done. Later on I've added the value of square is 8, is 64 and things like that. Now if I have print square over here, it will print all of these. So that is the difference in lists and dictionary. To determine whether a key is in a dictionary or not, you can just use the in and not in. You can just check 1 in nums, which will give a true. The next one is 3 in nums. This will give us a true. And the next one is 4 not in nums. This will also give us a true. This is not very useful for the smaller kind of dictionaries we have, but in a case where you're making a dictionary having 50 to 60 values inside it, 50 to 60 key value pairs inside it, then this will be very, very useful because you can't go on checking each and everything in the dictionary. Now, a useful method is get. Now, it does the same thing as indexing, but if the key is not found in the dictionary, it returns another specified value instead. So the value would be none. So actually now here in this thing, let's say we have got pairs get orange. Now this will actually represent orange because we have it. Next we have pairs dot get 7. We don't have 7, which means that it will represent a none. Next we have pairs dot get 1, 2, 3, 4, 5 not in dictionary. So this will also put a none because there are few values which are in the dictionary, few which aren't. So this is what the difference is. The next one. So for the next one, we have tuples. Now let's see what tuples are. So tuples are very similar again to lists, except that they are immutable, which means that again they are not, you cannot change them. Also, they are created using parentheses rather than square brackets. So this is actually a tuple. Now, like a tuple, for example, I have x as a tuple, then I can just store many values in it. Like, for example, in a variable, we store one value, but whereas in a tuple, we can store many values. So that is how it is. And using that one tuple itself, you can print out many values. So it's actually better to use a tuple. So indexing again starts with 0, same as a list. Now, trying to reassign a value in the tuple causes a type error. Now, for example, in the first case, you used the value of tuple 0 as stamp. I mean, the word 0 as stamp. But later on, you have decided that it doesn't work out with stamp. So for the next case, for the next function in your program, you need to change its value. So later on, you cannot reassign its value saying something like this. So this will actually be an error. And again, tuples can also be nested within each other. Now let's just look with a very clear difference between them. So for list, we have square brackets. For dictionaries, we have curly braces. And for tuples, we have parentheses. That is a very major difference which is actually visible. Tuples can be created without parentheses as well, just by using commas. An empty tuple is created using an empty parentheses. So here we have it. Now let us look at the next concept. So the next concept is list slices. So list slices provide a more advanced way of retrieving values from a list. If you have a list and you want to get a value from it, you can just use list slices. Basic list slicing involves indexing a list with two colons separated integers. This returns a new list containing all the values in the old list between the indices. This is actually a very clear thing. Now let's just understand this. Now here, this is 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, and 9. Now here, if I ask the computer to print the squares of 2 to 6, which means that it will print the square from 4 to 6 value, which is 0, 1, 2, 3, 4, 5, and 6. So the squares of all these numbers between 4 to 36 will be the output. In the next case, we have 3 to 8, which means that it will start from 9 and it will go until 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, and 8, which means that it will go on till 64. Next, we have 0 to 1, which means that both of these will be as the output. So this is how list slices work. So it's actually a very efficient way if you want to print many values at the same time. Like the arguments to range, the first index provided in the slice is included, but the second isn't. Which means that here, if I said 2 to 6, which means that all the values from 4 to 49, 1, 2, 3, 4, 5, 6. 36 will be printed. This is what we have seen earlier. But the actual thing is that only the values from 4 to 25 will be printed. 36 will be excluded here. This is something which we need to remember. If the first number in the slice is omitted, it is taken to be the start of the list. And if the second number is omitted, it is taken to be the end. Now here, if in this first case, we can see that we have nothing in the front and we have till 7. So all the values to the seventh thing in this list will be printed out. So which means that 0, 1, 2, 3, 4, 5, 6, 7. So all the values till here will be the output. And in the next case, it starts from the 7th value to the end, which means that all the things till 81 will be the output. Because 81 is the last thing. Slicing can also be done on tuples the same way we're doing it on lists. List slices can also have a third number representing the step to include only alternate values in this. So this is how it is. 2 is to 8 is to 3 will include elements starting from second index up to the 8th with a step of 3. Now here 2 is to 8 is to 3, which means that all the ones from this is the second one and 0, 1, 2, 3, 4, 5, 6, 7, 8. This. But all of these will not be the output. Only every third one will be the output. So let's say the 1, 2, 3. This, okay, we start from here, right? So here 1, 2, 3. The third one is 25. 1, 2, 3, 64. But 64 is not included because the last one is not included. So in printing, we'll get only 4 and 25. In the first case, we have from here, okay, now in the first case, we have from this to this with this state with a difference of 2, which means that all the values are to be printed, but only with a difference of 2, which means only the second alternate value is printed. So this is being printed 1 and 2, which means this has been printed, and so on. We'll have 16, 36, 64, and that is it. Because as we know, 81 is either ways not included. Negative values can also be used in list slicing and also in normal list indexing. When negative values are used for the first and the second values in a slice or an index, they count from the end of the list. So here, if a negative value is used for the step, this slice is done backwards using this as the thing, not this. A slice is common in an idiomatic way to reverse a list. Now, if I'm using something like this, the list is actually reversed and 81 becomes the first thing and 0 becomes the last. Let's look at the next concept. Next, we have list comprehensions, string formatting, and useful functions. So let's just start with list comprehensions. Now, list comprehensions are useful ways of creating lists whose contents obey a simple rule. So here we have a list comprehension, which is cubes for I with a power of 3. This is exponential symbol, which we have seen in the module 1. Now, for example, the value of I is 2. So this will be actually 2 to the power of 3, which is 8. But here we have it. So for I to the power of 3, for I in range 5. So for example, if the value, so here we have 5 is the value in 5 cube. 5 cube will be 125. So that is how it's going to work. And the cube which will be printed is going to be from 0 to 125. Sorry, 0 to 5. List comprehensions are inspired by set builder notation in mathematics. Now here, as you can see, a list of even numbers between 0 to 18. The range is 10, which means that every even number will be printed here. A list comprehension can also contain an if statement to enforce a condition on values in the list. So there are some times when you have to have a condition in the list. So using the if, you can do this. A list comprehension can also contain these. So the even numbers, I is I to the power of 2 for I in range till 10, which means that it will print all the even numbers from 0 to 18. And if this, and also this is actually the if we have used here is actually a check. Now, every square of 2 or every square of an even number will obviously be divisible by 2, which means that this has been used as a checking or a verification so that we do not make any mistake in the thing. Trying to create a list in a very extensive range will result a memory error. Now, if you have a very big list, now for example, 10 to the power of 100, which is very massive, so this will actually be a memory error because it takes a lot of time to do this manually as well. So by computer also it is really hard. This issue is solved by generators, which are covered in the next module. So make sure that you watch the next module as well. The next module is functional programming. But as of now, let's cover string formatting, useful functions, and text analyzers. So string formatting. So far, to combine strings and non-strings, you converted the non-strings to strings and then added them, which means that you used concatenation. String formatting provides a more powerful way to embed non-strings within the strings. String formatting uses a string format method to substitute a number of arguments. Now here we have string formatting. Nouns is 4, 5, and 6, which means 0, 1, and 2 is the index. Message numbers 0, 1, and 2. Format num 0, 1, and 2. This whole line of code actually converts this into a string, which means that we formatted them into a string. String formatting can also be done with named arguments. So if I have a value for x, let's say 5, and y, let's say 12, so they will be converted into strings. Next concept is useful functions. Now Python contains many useful built-in functions and methods to accomplish common tasks. So these are some of them. So join. This actually joins a list of strings with another string as a separator. Replace. Replaces one substring from a string with another. Starts with and ends with. Determines if there is a substring at the end and start of the end. Sorry. At the start and end of the string, respectively, to change the case of the string with lower and upper. This is actually when let's consider this line. If the line is starting with lower cases, you can just change the first word with the first letter as an upper. The method split is the opposite of join, turning a string with a certain separator in it. So these are all of these which you've learned above. We have numeric functions, which is max, min, abs, round, and sum. Now what is abs? To find the distance from a number from 0 and its absolute value, we use abs. Often used in conditional statements, all and any take a list as an argument and return true if all or any of them of the arguments evaluated true and false otherwise. The function enumerate can be also be done iterate can be used to iterate value through indices and lists simultaneously. Next, we have the text analyzer. Now, this is an example project showing a program that analyzes a sample file to find what percentage of the text each character occupies. This section shows you a file which could be opened and read. So here we have the file with open file name as ftext f.read. So this actually reads the file. This is all the file data. This is an exemplar data. This is sample content for demonstration. So with and as are used to open and read files. This part of the program shows a function that counts how many times a character occurs in a string. Now we have, let's say, character C, and in the previous output, it counts how many times C is being returned. C is being used. Next, the next part of the program find out what percentage of text each character or the alphabet occupies. A has 4.6 percentage, B is 4.94, and C is 2.28. So yeah guys, that's all for this module and hope you liked it. The project is already on my channel and this is actually a very interesting project. It's named as the longest word. So make sure you watch it and that's it for today's video. Thank you.